Welcome to Math Minecraft Computers episode I35, where we are going to build our second register using the simplified registers we designed in LogicSim last time. As you recall, these registers used 4 NAND gates to create a latch, and then used a monostable circuit on the enable line to make sure that we maintained the logic that we could flip the data after the enable. So that is what we built today. In fact, I've already built that circuit for you. We built it last time. I rebuilt it and I faced it west. You can see it right over here. Here it is. So there's the 4 NAND gates. The 2 middle 2 are hooked together with the enable, with the monostable circuit, which is this right here, with the block dropper hopper comparator, and then finally a repeater. That goes to the inside inputs of this. The outside inputs are going to the data, which you see I've already connected into bit 0 over there on the bus. And then it's inverted and goes to the outside here. Those, of course, go to these 2 NAND gates, which you see right here, and then they are crisscross connected. The output of this is an input into this one, and the output of that one is an input into this one. Over here is Q. I've created an enable line. This time I've labeled it with blue. I've labeled that register B, since we're tired of numbers all the time. So over here we have a register A, and this is the same 8-bit bus. They share the same bus, of course. So what we should be able to do is come over here and turn this one on. That sets bit 1. You can see we're now enabled here on the data side. If I flip this circuit, we should see the light come on over there, as you see that it has, and that our circuit is already off here, the monostable circuit. So if I leave the enable on, and I come over to the data line, and I flip it, you can see that it has no effect on the circuit. I have to turn off the enable line first, and now we're ready. So with this now off, I come back to the enable, flip it, and you can see our circuit goes off. So there is our working, simplified 4-gate storage device for a single bit. Now to make this into a register, we of course need to make 7 copies in this direction. You'll see I offset this just a little bit one off. There's going to be a reason for that, which you will see later. And I have enabled this in blue so that we can tell the difference between it and the Control A register. We want 7 of those copies. I'm going to pop up the homework flag. Can you figure this out on your own? Best of luck. Pause and see what you can do. So we are standing here, and we have the sun to the left of us, so we know we are facing south, so we know Minecraft copies in this direction and right to left. From the backward to forward in that direction for the Y coordinate, and then the Z coordinate is going to be from the bottom to the top. And so we will get our coordinates there. Just like last time, we're going to have to find where we start. We start 2 blocks down because we have redstone down there, down 2. So I'm going to put my target block here, and you can see popping up the coordinates. We have 261, 13, and 126. Of course, we want to copy the width of the circuit, which is as wide as this, and it is as tall as that because the torches are sitting on top. We have no bridges this time, so this is it. There you go, lined up. So of course our final destination of the copy is 276, 16, 134. All right, I'm going to go and replace this. We don't want the blue box. We'll make these white, and we'll put our redstone back. We're ready for the clone. Starting with our source block, which is 261, 13, 126. Going to the ending of our source, which is 275, 16, 134. Quick check. These should all be greater than those on the left. So 275 is greater than 261, 16 greater than 13, 134 greater than 26. That's always a check you can go through. Where do we want to put it? Keep in mind that we got to do our math first of all. So 275 minus 261 is the difference. We want to find a difference, we do subtraction. The difference between 275 and 261 is 15, but we have to add 1 for 16. The difference between 16 and 13 is 3. You got to add 1 to make that 4. And of course, the difference between 134 and 126 is 8. Got to make 1 9. Keep in mind we didn't start on 0 like we did with the ruler, so we just got to add 1. So our width, height, and length of this is 16, 4, and 9. Once again, just like last time, we want a space on the other side of this. We want to leave a space between the various components. So, do we want to move it to this direction? No, we don't. Do we want to move it up and down? No. We only want to move it 10 in a forward direction, so that makes this a 136. And there it is. There's 2. We just have to do that 6 more times. So we should have 8 of these now. 1, 2, 3, 4, 5, 6, 7, and 8. And I didn't copy my line, so we'll put those in, but that's really not that important right now. We'll do it just to make sure it's easy. And since we're down here, it's time to start wiring these up. Now keep in mind this is our data line right here, and in this case, it's going to be just the opposite of the other one, so I just need to connect that up here. Now we probably end up changing registers. It always seems to be that way. This one is going to go to the next one over, which is bit 6. And we continue to do this in all these cases. So let's do that. So that one on the enable line, that would cause some trouble. Let's fix that. Here's one of the problems. You see this is actually lined up right on the registers. Isn't going to be a problem. So we can go right over them, but we obviously cannot hook our line into there. At some point we will have to make a change. We're going to have to come down here and connect. So a couple of choices. You can't come down here because it connects to both. Our only thing to do is get rid of that repeater and put it here. And we'll see how that changes everything when we move on down the line. Next one. Okay, let's enable all of the data lines. And see where we need repeaters. Mostly over these bridges somewhere. Oh, did the same thing here. Hook up the enable line. Bad on me. Imagine if you just did a multi-million-dollar chip run. And you find out that's what happened. Your brand new CPU has a problem. Shame, shame. You gotta be careful there. Time to hook up the enable lines. Let's get a blue terracotta. And start hooking these up. Actually, I'm going to go down here at the same time, and I'm going to turn off all of the data bits. And we will turn on the enable line and make sure that it goes all the way down as well. And there's our last enable there. Okay, so we've got it powered. We just have to hook it up everywhere. Uh-oh, problem. Move this repeater back. Oh, this is always fun. That changes everything. Unless, of course, it is strongly powered and it carries on. The question is, does it? And the answer is yes. Due to a strongly powered block. Going to make sure that these are all powered. Because we copied, all the droppers have 1 unit of redstone in them. So we're set. This should work. It's time to test. turn off the enable. All the lights are off. What do we want to put? How about every other bit in this direction? There we go. Turn this on. And that's exactly what we get here. Off, on, off, on, off, on, off, and on. We'll just go ahead and turn the enable off. Can we put that over here on this register? Absolutely. Put the same value right here. All right, let's try another one. Let's go with the middle 4 on and the outer 2 on both sides off. So 0, 1, 6, and 7 off, and the others on. And there you see we have it. So that is our working. Simpler, much simpler register. If you look over here on the left side versus over here on the right side, we have only 4 gates per bit over here, and over here we have 8 bits. 1, 2, 3, 4, 5, 6, 7, 8 gates per bit with the inverter, and over here we only have 4 with an inverter as well. So this is a much simpler design. And this is what we'll be using going forward. It is because of the monostable circuit that we are able to do that. That is it for I35, the register type 2. Hope you enjoyed it. It is time to build more registers and transfer over the bus in I36. That's what we'll be working on doing. There's just a little few problems we need to solve, and then we can put a value in register A and move it to B and vice versa. So we'll do that next time. I36. See you then. This is Imroy. Keep on learning. Out.